All right, I'm back for the second part of the assignment, number 6, 7, and 8. So number 6 is a little bit of review with exponential functions. Since 1992, the value of homes in the neighborhood has doubled every 16 years. And so, one second, doubling every 16 years. So not every year, obviously, that'd be crazy if home prices doubled every 16 years, or every year. But every 16 years, it's a hot market, but it's not unreasonable. The value of one home in the neighborhood was $136,500 in 1992. Okay, so that's the home we're going to be working with. What is the value of this home in dollars in the year 2000? Well, the year 2000 is 8 years after 1992. So out of that 16-year time period it takes to double, this has happened in 8 years. So that amount, 136,500, and it's doubling, but only for 8 years out of those 16 years. Okay, so I'm going to use a fraction exponent since it's not the entire time period. And so 136,500 times 2 to the 8 16th is equal to $193,040.15. $193,040.15. We don't usually have cents on the price or value of a home, but why not? It's dollars and cents. For part B, write an equation that represents the growth in housing value as a function of time T years since 1992. So we have to remember that that doubling happens in a 16-year time period. And so if we want this to be every year, then we have to account for that like we did in the first one. So this is going to be, let's say V for value equals the starting value, 136,000. Wait, let me just double check. Yeah, we're going to use this example, 500. It doubles, but not until 16 years have passed. So I'm going to have T over 16. Okay. There are other ways we could have written that, but that's going to be the one I chose to do. All right. Write an equation that represents the growth in housing value as a function of time in D decades since 1992. So let's remember that a decade is 10 years. There's a couple of ways we could write this, but I'm going to just adjust inside the parentheses for this one. I think that would be easier because every decade it's 10/16 of that 16-year time period. And so I'm going to say, okay, so every decade. So 136,500, it's going to somewhat, like I'm going to use that 2 to the 10/16 as my growth rate because it's only 10/16 of that 16-year time period every decade. So I'm going to use D as my exponent for decade. Okay, use one of your equations to find the value of the home in dollars 1.5 decades after 1992. So if I use the first equation, I have to remember that 1.5 decades is 15 years. So I could do 136,500 times 2 to the 15/16. That would give me this 216, where is it? There we go, or $261,425 and about 70 cents if we round. So that's using my first equation. I'm going to use the second equation and just see if I get the same thing. So let's see here, 136,500. And then I said 2 to the 10/16 would represent the rate of change for a decade. And then for every decade. So now I am going to use 1.5 because it's 1.5 decades. And look at that, I get the same value, $261,425. and about 70 cents if you want to do dollars and cents on a home. All right, moving on, we've got two more problems, number 7 and number 8. Number 7, write two equations, one in exponential form and one in logarithmic form. To represent each question, use a question mark for the unknown value. We did problems like this in class the other day. So to what exponent do we raise the number 5 to get 625? So we're going to raise the number 5 to an unknown exponent and get 625. So that's in exponential form. In logarithmic form, the base is 5, just like the base of the exponent. But now it's log base 5 of 625 because the answer to a log is the exponent, so equals question mark. And for part B, what is the log base 3 of 27? The log base 3 of 27 equals question mark. Again, this question mark is the exponent. This 3 is the base, so in exponential form, 3 to the question mark equals 27. And finally, number 8, I'm just going to use my calculator for number 8 to settle it between Claire and Kyron. Claire says the log of 0.1 is -1, and Kyron says the log of -10 is -1. So thinking about this in like exponential reasoning. So if I think of, oh, that's right, without a base written, the log is 10. So Claire is saying in exponential, 10 to the -1 is equal to 0.1. And by the way, as a fraction, that is 1/10. I agree here. I agree with that. But Kyron is saying 10 to the -1 is equal to -10. And only one of these can be true, right? Because they both start with 10 to the -1. So it's either 1/10 or it's -10. Well, I mean, I know it's 1/10. So I agree with Claire. And then if I try and verify this on the calculator, just using their log statement. So this tells me the log of 0.1, and see, we get -1, so Claire is correct. And then interestingly, when I do the log of -10, it says error, non-real answer, okay? And the reason why is, remember the answer to a logarithm is an exponent. There is not an exponent in the world that will take a positive number and make it negative. That just doesn't happen. And so this is not true, and this is not true. So I agree with Claire. All right, and that is the end of your assignment. I hope the video was helpful.